Hi, in this lesson we're going to talk about BRDFs, the three different models that we have within our V-Ray shader. So we're going to open our scene O3 begin and we see three spheres. The only thing different is that now I've attached different shaders to our sphere. So the first one has a Phong material, the second one has a Blinn material, and the third one has a Ward material. Right now they have, if we go and look at the materials, they all have completely black diffuse. Let me move these things around. I'm going to move this out of the screen. We don't really need it. So it has completely black diffuse, completely white, pure white reflection, and a glossiness of 1. So the first thing I want to do is come on and open my Hypershade. We have here three materials. I'm just going to put them on my work area. Let me zoom out. And the only reason I'm going to do this is that I want to be able to control the glossiness of the three of them at the same time. So I'm going to create a V-Ray user scalar, which is pretty much like a number, a random number that you can use to connect to anything. And I'm going to connect my value to my reflection glossiness on the three of them. So by default, this value comes in 0.5, and you can see on highlight glossiness. I missed this one. This should have been reflection glossiness. Value, reflection glossiness. So here you can already see how the three materials are working different. So first, let's talk about what BRDF is. BRDF actually means bidirectional reflectance distribution function. Pretty much it's a mathematical model of how your specular highlights are going to work. In V-Ray we have three models. We have Phong, Blinn, and Ward. Phong one is the oldest one of the three of ones, was created by some scientist whose last name was Phong. It was created, I believe, in the late 60s. It's the most simple mathematical function for specular highlights. It's not used that much nowadays, but it's still there. It's the most simple ones. Then you have Blinn, which Blinn, also another scientist whose last name was Blinn, he took over the Phong and attempted to make the function a little bit better. It's one of the most used BRDFs models nowadays. It's very simple, it has great results, and it's relatively fast. And then we have Ward, which was also named after some scientist whose last name was Ward. It's the most complex of the three of them. It is not the most complex nowadays out there. There's a lot more complex systems, but it works really well. It has really good glossy reflection, it has really good blur reflections, and we are able to get non-isotropic or anisotropic speculars which are very useful in metal situations when we want to be able to recreate brush metal patterns and things like that. So I'm going to select this V-Ray scalar. I'm just going to call it glossiness master, and from here we can control the glossiness. So if we bring this up to 1 and just hit render, let me select the view and just hit render, we're going to notice no difference whatsoever in our three spheres. They're all going to look the same because we have our reflection at our reflection glossiness at 1, so we're going to get a mirror-like reflection. We're using pure white as a reflection. We're not using Fresnel or anything like that. We will talk about Fresnel in the next lesson or the one after that, but I just want to give you a quick show. So this is what we have. I'm going to cancel it. I don't really want to see the entire render. Now I'm just going to, in my V-Ray frame buffer, I'm going to select this area, and I'm going to start bringing this down to, I don't know, let's say 0.9, just so we can see a little bit the difference between these guys. From now on, every time I hit render, I'm going to pause the recording. You're going to notice the more we start building complex shaders, our render times are going to go up. There's not much we can do about it. I'm also working from an old laptop at home, so my renders might be slower than yours, but just we're going to not waste time looking at renders. We're just going to pause it and keep on going. So with this set to 0.9, and the other thing I want to make sure is that I want to add my reflection, my specular, and my sampler rate. I don't know if we're going to have enough time in this video to talk about sample rate, but it's something that we will be looking at just so we understand how the DMC sampler works with our glossiness. The DMC sampler, it's by itself a very complex subject. You can find entire tutorials that would talk for almost an hour trying to explain you how the DMC sampler works. I will just give you a quick recap of what it does, just so you understand how it's affecting your render times and your shader qualities. So now this, with our glossiness set to 0.9, hit render. Okay, now render is done. We can see from the results the font has very little difference from our original render when the glossiness was set to 0.1. We just have a strangled specular highlight. In our blend material, our reflection is a little bit blurred, not that much, and our specular highlight, it's bigger. On our word, on the other hand, it's way blurred. We have some noise, what some people would call fireflies, which are these bright dots here, and our specular highlight is way bigger, and it has changed its shape. If we come and look at, I didn't add this, which was something I wanted to do. I'm going to add it for the next render. Make sure we have reflection, sample rate, and specular. But you can start telling the difference. Also, the more blurry your reflection is, the slower your render is going to go. So you can tell right away that word is going to be the slowest renderer, blend the middle one, and funk the fastest. Very few people use the Funk BRDF model nowadays. Most people will use Blend or Ward. Blend is an excellent one when you want to use very simple specular highlights for things like plastic, ceramics, wood, I don't know, most things that don't have a very strong specular highlights. When you're working with metals or conductive materials, Ward is going to be the model to go. Especially in V-Ray, there's really no other way. When you're using different renders, there's better BRDF models, but for V-Ray, we're just going to work with these three. So in real life, you're going to be using Blend and Word 99.9% of the time. I cannot recall the last time I had to use a funk shader. So with this said, let me pick my glossiness master again. I'm going to bring it down to 8. I just want to show you guys a small comparison of what's going on here, and I'm going to hit render again. Okay, render is done, and you can now see very well the difference between the three shaders. The lower we bring our glossiness to, the more this difference can be appreciated. So funk almost looks like what the blend was looking on our last setting, on our 0.9. Now blend, this is what most of you guys are used to using. It's blurry and it has a strong specular highlight. And our word model has just gone almost unrecognizable in terms of reflection, and the specular has become bigger and more deformed. If we look at the specular, you can see here what's going on. So let me zoom in. Here, this is the reflection of the HDR, like the specular of the HDR, and this is from a sphere light. This is now a really nice specular highlight. We have like some fuzzy edges, then we have the strong specular for our light, and here, pretty much both of them have merged, and we have this big shape. The reason I wanted to show you this is because a lot of times when we're building our shaders, we will be building shaders by combining more than one blend shader, more than one word shader, or in sometimes we will want to use word speculars on top of blend reflections and things like that. So I just want you to really see the difference between these three guys and how they behave different to the specular highlights or our reflection of light sources. The next thing we're going to talk about in the next lesson, just because this video has gone over 10 minutes, is going to be how the DMC sampler, it's sampling our shaders, and how as we start bringing down our glossiness, we're going to need more samples, whether we want to use them in the entire scene or we want those samples to be specific to this shader, and that's when the sample rate is going to be really effective for us to notice where we need more samples. So I'm going to stop here. We're going to continue working on this same file for the DMC sampler, so I'm just going to save it as O4 begin. We're going to talk about the DMC, and after that, we're going to do one more recap about the Fresnel curves or the reflectance curves, and then we can start building shaders. I know there's a lot of recap going on, but I just want to make sure you all guys understand what I'm talking about when I start talking, like when I start layering shaders, you understand why I'm doing it. So we'll continue on the next lesson.